This question is about the chemistry of the Earth's atmosphere. The figure below shows how the percentages of gases in the Earth's atmosphere have changed since the Earth's atmosphere was formed. And you can see that we've got a graph here. On the x-axis, we've got millions of years ago, and it goes 4.5 billion years ago, in fact, at the origin. And then we've got the percentage of gases in the atmosphere at that time. And as we work our way to the right, we're getting closer and closer to present day, which is the time zero. This is how long ago, so this is present day. And you can see that we've got three gases on the graph. We've got carbon dioxide, which is the dotted line, so this line. We've got nitrogen, which is the dashed line, so here. And oxygen is the solid line. And we've been asked to explain the change in the percentage of gas in the region labelled A on the figure, on the graph. And so when you're asked to explain, that means give a simple description and then give the reason for it. So make a point and then explain that point. And so we need to find the region labelled A. And inside that region labelled A, we've got the dashed line. So that means we're talking about nitrogen. And so in terms of an explanation, the change first and foremost is, well, this value is going up. So the percentage of nitrogen was increasing. Don't get bogged down by actually quoting values. Just simply say the percentage was increasing. And the reason that the nitrogen levels went up is that nitrogen was produced when volcanoes erupt. So we would say volcanic activity, or it was released when volcanoes erupted, or something like that. So one mark for the fact that the nitrogen increased, and another mark for linking it to the fact that it was caused by volcanic activity. And then we've been asked to explain the change in the percentage of gas in the region labelled B on the graph. And so B is the dotted line, which means it's to do with carbon dioxide. This time it's starting high and it is going down. And so we will get 1 mark for saying that the carbon dioxide is decreasing. So like in the previous question, we need to personalise it to the gas that this is representing, but that's just a case of using the key correctly, and we need to say what the trend is. So the carbon dioxide is decreasing. And then for our deeper explanation, we're giving a reason why this CO2, with this carbon dioxide, is going down. And there are a number of reasons why it's going down, but we need to be careful because this is more than 4 billion years ago. And so we need to steer clear of photosynthesis. That was the most common wrong answer on this paper, because photosynthesis hadn't happened until much more recently than that. So the reasons why the CO2 decreased is that carbon dioxide dissolved in the oceans that formed when the Earth cooled down. So the Earth cooled down, and that meant that the water vapor condensed to make the oceans, and then carbon dioxide dissolved in those oceans. And then that continued to happen, and also the formation of carbonate precipitates or sediment or limestone or carbonate rocks, all of those things kind of fall together once there's an ocean and that there are carbonates in the ocean. So again, the first mark is for simply stating the trend that the carbon dioxide is going down, and the second mark is for saying one of the reasons why it's going down. We don't need to give lots of reasons, just one of them is fine, because we're developing our first statement of the decrease in carbon dioxide. Next, we're asked to compare the changes in the percentages of the gases in the region labelled C in the figure above. So this is just a little bit less than 1.5 billion years ago. And so when you're asked to do a comparison, you need to say whether things are the same or whether they're different, and if they're different, which one's bigger, which one's increasing, which one's decreasing, etc. And so on this occasion, we're comparing the oxygen line, that's the solid line, to the carbon dioxide line, which is the dotted line. And what we can see is that the oxygen line is going up as we get closer to present day, and the carbon dioxide line is going down the closer we get to present day. And both of those two clauses are essential for the first mark. The carbon dioxide is decreasing and the oxygen percentage is increasing. But that's not really a comparison yet. We have given a simple comparison, I suppose, but we've not gone deeply into that. But what we need to notice is the rate of increase in oxygen is the same as the rate of decrease in carbon dioxide. It almost looks like almost looks like an X that is perfectly symmetrical. And that's where the second mark is going to come in. The increase and the decrease are occurring at similar rates, or maybe you could also say the same rates. They're not going to double check this in terms of the precise language. We aren't expected to know exactly what the gradients are. So the increase and the decrease are similar in the same period of time. And then we're asked to say what the cause of these changes in the region labelled C is. And the cause of this change is photosynthesis. The trees and plants in the early Earth will be taking in that carbon dioxide and releasing oxygen. But you can simply get this from just saying photosynthesis. And this makes sense that it would be exactly equal and opposite, because if you consider the word equation for photosynthesis, we have got carbon dioxide and water turning into oxygen and glucose. And then if we turn this into the symbol equation, you can see that there are 6 CO2 being used and 6 oxygen being produced. So it's very logical when you see this that the use and production will be equal and opposite. So they're taking place at the same rate during the process of photosynthesis.